Hi, everyone. Welcome to the Poultry Podcast Show. I'm your host today, Karen Grogan. And my guest today is Dr. Lilong Chai, who is one of my colleagues from the University of Georgia. Lilong works as an assistant professor and engineering specialist within our Department of Poultry Science. And his sort of specialty area is air engineering, air quality, precision farming, and he has a extension role, which we'll probably talk to kind of what his jobs are with extension. Lilong came to us from Iowa State University. I'm sure you enjoy the warmer weather here in the South. Lilong, why don't you tell us a little bit about your background and your training and how you became interested in engineering as it relates to poultry?
Hello, everyone. My name is Lilong Chai. Currently, I'm an assistant professor and engineering specialist with Poultry Science Department at UGA since 2018. Prior to that, I was a postdoc research at Iowa State University in the Department of Agriculture Biosystem Engineering. During my postdoc training at Iowa State, I participated in some USDA NIFA grant project, including one is related to the avian influenza prevention, like transmission of airborne bacteria and AI, how we are using engineering technology to prevent the transmission. My PhD was joint training between China Agriculture University and Purdue University. So in the past few years, I studied in different countries, China, USA, and also Canada. I was working with Agriculture Canada for 3 years as an intern postdoc fellow from 2012 to 2015. Then from 2015 to 2018, I was with ISU, and then I joined UGA.
Excellent. Out of the places that you've studied so far, what's been the best experience for you?
I would say I learned a lot from each place. Like at Purdue, I participated in a very large project called National Air Emission Monitoring Study, NAMS project. That was a $50 million grant supervised by EPA. And I was so luckily got a chance to work with a lot of famous scientists because Purdue gave a subcontract to 8 other universities from Cornell in East Coast and UC Davis in West Coast. So I was working with a lot of scientists remotely.
Right. So it's a large collaborative grant. So that was a good experience as a student.
That project brought me into the area of animal environment, animal production. Then in Canada, Agriculture Canada, that's similar to the USDA and the government agency. I was working on the emission modeling, how greenhouse gas ammonia emissions can impact the environment and ecosystem. My job was developing a region ecosystem model, not a national model, but looking at detail of each province, like Alberta, Ontario, and also other provinces of Canada. So my model can predict emission inventory from each province. Similarly, I'm currently developing a similar model for Georgia. We want to predict ammonia and greenhouse gas emission from Georgia poultry production, because poultry is a very large sector of the Georgia agriculture system.
Right. We have some pretty concentrated areas of production. And in terms of that modeling, is that per farm site or you do it like over a county basis? What size does the model predict?
We can do both. The input included like how many numbers of bird you have. Is that the broiler or layers? Because they have different emission factors. And for the specific farm, if you are using any mitigation strategies, like ammonia emission is affected by pH level of manure or litter. If you are using litter additives, you may control some emissions. And for the state level, we will do the statistical analysis on a lot of data collected from different counties. That's correct. Because each county has a different climate zone, like what's the 30 average temperature range, what is the rainfall, because rainfall can affect emissions from open area. If we have manure stored in the open area, then it could be impacted by rainfall. and also the wind direction, wind speed as well. And the time of the you're applying the manure for the crop production also matters for the emissions.
Right. So, in terms of mitigation strategies, what types of things is your lab currently working on to try to either reduce or improve or mitigate the emissions that poultry production farms are adding to the environment?
That's a very good question. For the emission mitigation, we have two goals. First, improving the air quality. If we reduce the emissions, that means we will improve air quality, especially the ammonia. If the ammonia level is over 25 ppm, potentially animals' welfare will be affected. That is regulated by NIOSH, National Institute of Occupational Safety Health. Currently, in wintertime, most chicken house has higher than 25 ppm. That we are sure animals and their caretakers are on the risk of like a health issue, welfare concern. So if we're using any lead additives, like lead additives primary component is acidifier, so we can reduce the liter ammonia pH level. In that way, we can reduce ammonia emissions. The other concern is the dust. Sometimes the dust level is very high in the chicken house, especially cage-free layer house, because birds are freely moving everywhere. They are jumping, perching, so dust level could reach 20 milligram, like PM10 or PM2.5. Then it can reach 5 or 10 milligram per cubic meter. That's a very high level. If the ambient dust level is higher than 0.5 milligram per cubic meter, that is a red alarm for some countries. We cannot see anything. If you're in the chicken house, the situation is 10 times worse than that kind of situation. That's the first goal is improve air quality, because dust can also carry bacteria, virus that will lead to infection to the animal respiratory system, or PM2.5, that's fine particulate matter that can enter the lung and other part of our respiratory system, can lead to a lot of issues. So the goal one is improve air quality. From a chicken house to our other side, that is emissions. So we wanted to reduce the environmental impact by using, besides lead additive, we're also using like electricity charging system. If let's use charging the airborne dust, or ammonia can be charged as well. All kind of particles, gases can be charged by minus 20, 30,000 voltage. The charge is the particle that is negative, so no dangers to animals. Charged particle will go to the wall, ceiling, or ground floor, so that air quality can be improved. In that way, the total emission from the house to ambient will be reduced. There are many other methods we're considering is like air filtration system, by install the charging system in front of exhaust fan. So the exhaust air like dust, ammonia, greenhouse gas could be filtered. In that way, we can reduce the environmental impact.
And in terms of that type of system that would go in front, so an electrostatic system would go in front of the exhaust fan. Is that a model that you're currently working with, or are there farms that have that already in place?
That's a part of the model. That could be a mitigation factor. We are testing the technology to quantify how much dust ammonia can be reduced. Not in Georgia.
By that.
Mm-hmm.
Okay.
Currently in Midwest, in Midwest layer farm really, and also swine farm, they really care about odor as well. The company, EPI company, electricity ion precipitator, or they have different names. That system can be installed for some swine farms in Iowa. Yeah, I have a friend work with the swine farm. I visited the place a couple times. They said the system were good in odor control.
Okay, that is definitely a concern for all of sort of these what we consider concentrated animal feeding operations, CAFOs. I think odor, especially other states that have swine, poultry, multiple agricultural entities. I think that we see a lot more complaints from neighbors in terms of odor.
That's correct. The same thing about poultry farm. If the neighbors smell that, they may be complain. And that's a big issue for the farm to expand the production. That maybe requires a county hearing. So if the farm don't have this kind of technology to prevent the transmission of odor, other gases, they maybe cannot get approval. So that's why our research will help the poultry industry to get the approval in the future.
Perfect. So that they have the things in place as the houses are being built. In terms of sort of like retrofitting our current houses with some of these technologies, is that something that you see as a possibility? Are these technologies going to be, put in existing houses as well?
Oh, yes. For existing house, inside of the house, I did some tests in commercial cage-free house in Iowa to control the dust and also the summer heat stress by using the sprinkler system.
Okay.
The sprinkler system was originally designed for dust control because dust came from the litter. The litter in wintertime, is very dry.
Very dry.
Mm-hmm. The ammonia was not a concern at that time, but dust could be reached very high. So if we wetted the litter surface a little bit, not too much, if we added too much liquid, the ammonia level could be very high. So we did the lab test at first. Then we quantified that 3-gallon water spray could reduce the dust level by 50% without causing ammonia issue. So we installed the sprinkling system in a commercial house, and that controlled the dust by 37 to 51%. That reached our goal. Another application was in summer cooling. In Midwest, just different from Southeast, we have a sprinkler cooling or evaporation cooling pad in Georgia, North Carolina, but not in Iowa, Indiana, because farmers' concern is winter heat, cold stress. They don't want the house has any heat breacher or on the cold environment, the bird would suffer from a cold stress. In that way, the feed consumption will be high. The feed consumption accounts for over 50% of production cost. So that is the producer's concern. But birds are suffering in summer. So we propose to use sprinkling system for the cage-free production.
For cooling. Mm-hmm.
Yeah, and the farm managers were nice, accept our suggestion. We tried that, and we reduced surface body temperature by 12 Fahrenheit degree after 20-30 seconds spray.
Excellent.
Yeah, and I use the thermal imaging technology. I use thermal cameras to monitor and quantify the heat stress of the body temperature. Like by put the camera on the ceiling, we can see the floor birds, and the bird temperature, body temperature can be quantified. We compare the picture between spraying and after spraying water, so we know we did improve the cooling efficiency, and the bird definitely was happy about that. A lot of birds from the avian system, they would jump into the floor to get some cooler water.
They do know how to find the comfortable areas.
Yeah, the birds are very sensitive to that. And also use a thermal imager, we can monitor their flow distribution. We know that a lot of birds like to congregate at a place with a little bit of dripping cold water from city. That means they want cold water. So we transfer that information to produce farm manager. Told them you may need to flush your water line. The bird like to drink cold water. They are under the heat stress. So the farm did the same thing as we suggested. So we're happy we can reduce the heat stress of birds.
Yeah, you're doing a lot of interesting work in terms of new technologies entering into engineering. What are some things that you see coming, like artificial intelligence? That's kind of a buzzword in terms of many industries. How do you see that applied to our poultry industry?
That's a very good question. And nowadays we talk about the precision poultry farming, precision laboratory farming a lot. Actually, that's not a new concept. We have been working on that for like decades. Previously, about 20, 30 years ago, people are looking at air quality, environmental control, and ventilation, cooling. That is the earlier version of precision production. By doing that, we can provide birds, animals with optimal environment so they can maximize growth speed, can feel comfortable to produce all the year round. Nowadays, we are focusing on animal welfare because we can maximize the production already. But a lot of people, especially the animal industry, they care about animal welfare. Like they want customers, um, salesperson, or the restaurant chain. They're interested to know where the chicken come from. If the chicken had a good welfare protection.
Is the chicken happy while they're laying eggs? That's
Exactly.
that's what they want to know. Yes.
Yeah, to answer their question, so we are using different technology, sensing system, imaging technology. I could share some imaging technology research in my lab. We are install camera in the chicken house to monitor their flow distribution.
So like in an aviary system.
Yes, aviary system, and also
Mm-hmm.
broiler house as well. Yeah, the birds, no matter layer or broilers, their behaviors can be analyzed, quantified to connect to their welfare indicator. For example, for broiler chicken, a big issue is a leg issue or lameness because they are growing so fast nowadays. So their body weight is so high. So also heavy bird tend to have leg issues because of fast growing speed. But their legs are compared to their body weight is not well developed, so they tend to have leg issues. Not all the bird, maybe 20%, 30% of bird have leg issues by the end of the flock, but that's a big issue. A lot of people think we should go back to slow-growing chicken, like a lot bird to grow 3-4 months. But don't forget we have like 9.5 billion people to feed.
Right. We have a lot of people to feed in the world. If we grew everything that slow, we wouldn't be able to feed.
Yeah, we cannot sacrifice our production efficiency. So one method I'm thinking is using imaging method to track the individual bird with leg issue. Because we found the bird with leg issue like to stay close to feeder or water because they are less mobile. So by monitoring their flow distribution, we can narrow down the group, the bird with the leg issue. In that way, we maybe do something to encourage the bird to move a lot, to encourage the bird to do some exercise. Maybe it can improve the leg condition gradually.
Right. A lot of the welfare parameters we measure are very subjective, and the technology you're describing would, be able to assign, a measurement, like a visual measurement or where they are located. Like you would take some of the, the people, their eyes, like say we've used gait scoring for years to measure lameness, but the technology that you're talking about is definitely taking some of that subjectivity out of that. And that would be really, I think that would be useful. That would improve auditing. That's another, point that we could audit on welfare audits. So look forward to that. Yeah, that would be great technology to add.
Yeah, besides the broiler house, in cage-free laying house, or the regular laying house, conventional production, bird have pecking issues. Like the bird like to peck each other. That's a natural behavior. We cannot like big trim bird anymore nowadays. So we are developing imaging method to track pecking behaviors. We found my student has developed a model that can quantify the pecking numbers over time. If we notice the pecking number is very high, we maybe provide some prevention strategies like a pecking stone or pecking block made from a grain material. Birds like that because after pecking, they can get some either grain material or other stuff. So we are not just stop their pecking because their natural behavior. Instead of pecking on the birds, we are encouraging them to peck on the stone, on the blocks. So in that way, we can reduce the pecking damage on the birds. That's another project we are currently working on.
That would be great. That's a constant struggle in both, broiler breeder production and layer production. Just and it's not predictable. You never know. You'll have flocks normal for a long time, and then all of a sudden they're very affected by pecking. So that would be great to try to figure out some of those parameters, because sometimes it doesn't make any sense of why, what triggers it. But that would be good to have some alternative solutions. So you had talked earlier about, dust in the environment carrying viruses and bacteria. One virus that we've dealt with a lot this year, and I think that you dealt with in your time at Iowa State, is avian influenza. So we are continuing to have positive cases here in the United States. We thought things had slowed down, but here we've had a couple more reports here in the past week or so. What in your research, how did you guys, your research team, look at how avian influenza was either carried into houses or transmitted out of houses? Was there work to sort of help us understand the transmission of that virus?
That's a good question. I can share a project I did at Iowa State. That was led by Dr. Hongwei Xin. He was my postdoc mentor during the 2014-2015 outbreak HPAI. The Dr. Xin applied a grant from USDA and NIFA to study how to prevent the AI transmission over air. During that time, my team, Dr. Hongwei Xin and Dr. Yang Zhao, they both faculty with University of Tennessee now. They sampled the air from the farm, infected farm, and they found the positive virus over there. And then they confirmed the airborne transmission is possible. And later, we did a modeling study led by Dr. Zhao, and I was the co-author of the paper published. We did a modeling, and we found even like the dust, PM 2.5 or PM 10, they can carry wires from like Minnesota farm. Then if the wind is blow from the north, maybe take a couple days to Iowa, and then downwind. We did the modeling meanwhile, we did an air filtration study. We confirmed that airborne transmission is possible because a lot of farmers did a very good biosecurity management, but still the spread of the AI so fast. The other very high possible reason is airborne transmission. Like if the farm is infected, so the downwind farm could be affected by the airborne dust. The dust can carry wires. So that's our original plan. We think if we can reduce the dust from entering the chicken house, maybe we can reduce the contamination, reduce the infection. So we select a commercial farm in Iowa, in North Iowa. We started the electrostatic charging system and also air filtration, the filter as well. The filter can block dust, but not in very high efficiency. But if we charge the airborne dust with like 30,000 voltage of the electricity, the dust filtration efficiency can be reduced further, like we reached 80% of reduction efficiency.
So that electrostatic charging device would then basically keep the dust on the farm and keep the virus on the farm.
Yeah, we block the dust in the filter, so the farm the dusty air won't enter the chicken house.
It's not exhausted out the end of the house like we all have likely seen. Yeah, the dust definitely.
We installed the filtration system in the inlet.
So it's filtered as it comes in. And do you think that those types of systems will become normal, part of our, or only in high risk areas?
Oh, that's a good question, because that filtration system can affect the ventilation efficiency. So maybe wintertime is okay, but not summertime. Some heat stress is an important issue. Our suggestion was to use that in the high risk area. because if we have surrounding farms or surrounding state have the infection, has positive cases, so the downwind farm installed in the system. So that may be we're not 100% sure that it can reduce, but we are sure that it can reduce the risk if the virus is from the airborne dust.
If it's airborne transmission. And what distance did your research and the research group that you were part of, what distance was documented for the virus to potentially travel in the models that you used?
In the model that was led by Dr. Yang Zhao, we tried the distance were large range from Minnesota to Iowa, then to Kansas, were large area, and our resolution is can be as 5 or 10 kilometers. We can, by reducing the distance, that's in that way we can improve the model accuracy.
Okay, so in terms of like documented cases of airborne transmission, like you studied those to develop the model, or how was the model developed to predict that?
That model was developed based on a survey. We know many farmers was infected, so we did a survey, and then we based on the statistical data provided by state agriculture department. Then we use that as input.
Gotcha. I think that when we're in an outbreak, there's so much virus that's likely circulating, and I think that's just that would be another control point if we could try to keep the dust and the virus on the farm. That would be helpful.
Yeah. Besides that, some other technology we maybe consider, like reduces the contamination from wild birds. We know the wild bird can carry avian influenza, but we cannot control wild bird. I noticed research at Wageningen University. They use install a laser around the farm, so the laser will scan the area. So if any wild birds, they were expel the wild birds away.
Oh wow! And the lasers are
just like light.
Just the light. So the light just keeps them away. Okay. So it's a deterrent for wild birds.
Yeah. Also, we are thinking about using imaging system to monitor the farm. If we catch any wild birds fly close to the farm, we maybe can use either laser or other, in some Amazon has $50 like alarming system, make a loud noise to expel the bird.
To get the wild birds to go.
That's another thing we were thinking. Maybe can reduce the potential contamination.
It's a good thought. We definitely know that there are lots of wild birds and not necessarily just ducks anymore. So yeah, other wild bird species can carry the virus and bring it onto the farm.
Yeah, every time I visit a commercial farm, I notice some wild birds because the farm has the feet.
Yeah,
so the bird can smell them
everywhere. Yeah.
They like to get closer to get some food. So.
That's right. Free food. So in terms of sort of what you see as the future for precision farming or, air quality, what are some technologies that you're really excited about? Like things that would be, 5 to 10 years down the road?
I would just say maybe in future, blockchain technology can be used for the poultry production as well. No matter animal welfare or the carbon footprint, that can be quantified on the farm, and then that's the database. By using blockchain technology, we can track the product. For example, if you go to Walmart, McDonald's, you may just scan a bar. You can find out where the eggs or where the chicken was produced and how the animals was growing, what the background story looks like. Especially now, customers are interested to know the meat or eggs, the related welfare information, carbon footprint. Last year, USDA and RCS released a project called Climate Smart Agriculture and Forestry. I think that's a very good opportunity to improve the precision technology by tracking the carbon footprint. For example, we are developing mitigation technologies, and that can help reduce the emissions. But the cost is high. We need the compensation from either government or from the grocery. Now, no money for that part. But if we can use blockchain technology, then it can improve the market value of the product. For example, some customers are willing to pay like 10% or 20% higher for the specific product they like. That's where the money can be used to improve the technology.
We definitely have consumers that they're always looking for the next best thing. And I think that, what you're describing, that would, they all want something that they can scan on their smartphone and know where their chicken nuggets came from.
Yeah. With a smartphone, we can just use app. Now we can check the farmer situation. And another area is the cloud computing. We talked with commercial producer farmers. They don't want to spend like $1,000, $27 for the computer because the images, videos requires supercomputer to analyze. Instead, they are okay to pay like $200 per month for the data service. Now, a lot of companies like Google, Oracle, I have a project with Oracle, we're doing cloud computing. By uploading the images, the video to the cloud system, we can use their cloud computer, like GPU computer, to do the data analysis. Then it can improve the data analysis in a very efficient way. And we don't have to spend money for the computer. The company has. We just need a high-speed internet. That's relatively cheaper. So the farmer just uses the cloud infrastructure provided by the company. They pay like $200, $300 per month, and they can use the app to connect to their cloud computer system. So the farm manager, maybe in the future, just sit in the home or office to check the bird growing condition. The system can report like nest score, heat stress conditions, growth speed. Definitely, all the farmers interested to know their body weight. So in all my technology, I would just say we should include body weight of broilers, of egg production for the cage-free layers or conventional layer production, include their interested data together with animal welfare data. So all stakeholders will be happy.
The future will be here really quickly with all this technology. It's developing every day and being applied into our industry. Well, I thank you for your time, Lilong. I think that we have talked about some really interesting subjects in terms of air quality and how technology is going to take us into the future so that our industry can be more sustainable. So if all of you listening, if you have any questions directly, you can find Lilong on the UGA Poultry Science webpage. You can find him there pretty easily and send him your questions. I hope you have a great day. Thanks for listening.
Thank you.